In March 2019, at Sabre, we made a little bit over 3,000 changes to our production systems. All those changes at that time were executed manually by our engineers. And now, fast forward to March of this year, we made a little bit under 8,000 changes, and half of them were implemented by our CI/CD pipeline. This is the progress we made in just 4 years, and this is the content for today's. This is the main topic for today's talk. I'm Jacek Ostrowski. I lead platform engineering at Sabre.
And thanks for that. My name is David Browne, and I work with our SRE team and our CI/CD and other groups within Sabre. So just briefly, this is a case study we did discussing our journey, as Jacek said, on our journey into the cloud and different attempts and things that we've done over the years. A little bit about Sabre. This comes partially from our legal department on what we can describe, but we are a multi-billion-dollar company involved or in the technology at the center of travel. We actually ended up spending $100 million in 2022 with a continued spend this year and additional spend scheduled for next year in transforming our technology. As far as the actual technology behind this, to put a little bit of scope around what Sabre does, we do about 1 billion API calls a day through our external gateways with customers, which equals about 1.3 million calls every minute. And that equals, of that, about 130,000 flight searches every minute. So this would be from OTAs like Expedia, partner with us or have partnered with us in the past, as well as all the airlines that when you do searches on the internet for flights. Back in the 2010s, this was all spread across multiple on-prem data centers, as well as mainframes, as well as a little bit floating around in the cloud and virtualized data centers. And this is kind of the environment that we ran on. We had thousands of VMs running in these different areas. And that's when we began our journey into the cloud. For some of the reasons behind that, though, I'm going to pass it over to Jacek to talk a little bit about what the cloud means to a company like Sabre.
It's for those discussions, it's good to understand the kind of reasons, what the key drivers for big decisions. And in this case, like, we have to anchor this in our customers. We are working in the travel business, and especially airline business is pretty complex. There are multiple variables from the fuel prices to weather that impact demand for travel. And if we have fluctuating demand, airlines usually don't like to fly empty airplanes, so they organize sales. Those sales are very beneficial for the passengers, they're good for airlines, but for us, this is a challenge because those sales generate a spiky demand for our services. And those spikes can be huge. We are talking tens and hundreds of servers. One of the potential solutions for this kind of problem would be to over-provision and have a spare capacity on the floor, but that's not a financially sound solution. So in the past, we approached this problem by asking our customers to request in advance the capacity. So basically plan this in advance. We put a lead time for those kind of events. And that worked. That worked for a long time. But as our customers started using cloud for their own infrastructure, they saw the benefit of elastic computing, and they wanted to experience the same kind of flexibility from Sabre. We, on the other hand, we wanted to be competitive, and we wanted to fulfill those needs from customers. So we saw that, okay, we also have to adopt cloud. This is just an example. This is one of many reasons behind our move to the cloud. Another important reason was basically cost. We operate 20,000, 30,000 servers. At that scale, we can have some scale effects. We can expect some efficiencies. But comparing this to scale of millions of servers that Google or any other major cloud vendor manages, this is nothing. At that scales, you can have those level of efficiencies that we would never be able to unlock. So we saw this as an opportunity for us to drive our cost down. So we had a cost, we had a customer problem inside, And long story short, we decided to move to the cloud. So let's look how our journey looked. At the very beginning, urgency for our journey for the migration was very low. The first phase, this is just exploration. We are very curious and we want to learn, but at the same time, we don't want our new tools to impact our customers or to impact our brand. So let's look deeper how we were set up.
So from a technical perspective, I can give you a high-level overview of what our first foray into the cloud kind of looked like, and it's probably going to be familiar to a lot of people. So back when we're starting to look at the cloud, our first cloud selection at the time, we were looking at AWS, and we had teams that were building our applications. We were using Bitbucket and Git at the time, along with CVS and Subversion and older systems as well. But a lot of teams would go and build their applications. They'd set up a Jenkins instance or TeamCity and be able to build one of their applications. When they wanted to go and deploy it in our development environment, we had very, very few rules, basically almost no rules. You could go and stand up a Jenkins. You could set up a pipeline in Jenkins that would be able to automatically build and deploy your artifact into some form of development environment in our cloud in AWS. So this worked well from a development standpoint. Developers were able to move, try some things out. But as Jacek said, we had a lot of rules for certification and production because we did not want to impact our customers. When we impact a customer, unfortunately, it tends to show up on the news if people can't book check into the hotels, or if you can't book on a flight and you see lineups at airports. That's very compelling for the news. So we have a very low risk tolerance for impacting production customers. So we have a lot of rules around what's required to go into certification and production in our environments. And so those rules and policies were given to the developers, and most of the developers had to figure out on their own for their product, what does it look like as they try to execute that in the cloud. Approvals then were still manual under this model. So you had to do a change request. We were using ServiceNow to allow teams to do that. They would have to go and manually fill out the form, go to a cab to describe what change they're making, what's the risk, and all of that was manual again. And then when the development teams actually moved to execute their code in certification and production, the networking was not allowed to allow teams to run what they ran in dev in certain production. So they would actually have a separate pipeline that they would configure in certain production. It's really a pipeline because in most cases, it was a combination of manual scripts, manual steps that might be executed, maybe a Jenkins server that was set up to do some steps of the deployment. A lot of teams used open source Ansible to be able to go in and use a serverless access to execute some scripts on various servers. And so it was some combination of that. Most notably, though, in all cases, it was different from the application pipelines the developers set up in development, which really created this issue where, yes, we had some stuff in the cloud, but what we did in development was not what we saw in production. And it also didn't give us the speed that we were looking for because there were a lot of manual steps, manual approvals that were still involved in this particular process. So that's kind of our first foray in the late 2010s as we moved into the cloud and started looking at it. The other issue as well is each of the teams had to learn what to do by themselves. And so there wasn't a lot of sharing of what they did in production. Each team had their own pipeline that they created and their own solution to the governance and rules that we have around certification and production. From an organizational standpoint, Jacek will describe a little bit about what we had.
So the way that we organized was we very quickly created a Cloud Center of Excellence. That was the team that implemented most important policies and created cloud landing zones for us. So that was like a first layer. On top of that, we had our cloud governance. And the key focus for cloud governance was to limit access to the cloud only to teams and products that have a lowest risk of impacting customers. And that model, that worked well. We accomplished what we wanted. We wanted not to appear on the news, like David said, and we didn't. We didn't have any major problems. The key finding from that time was that we moved very slowly. Because we limited exposure, we limited number of teams working with the cloud, we proceeded slowly and we learned very slowly. So after some time, we were at the point where we noticed that if we continue on the same trajectory, we won't be successful and we have to change something. So that was the end of the phase 1, and we started to phase 2. In the phase 2, the urgency of our cloud migration increased. The risk profile was still pretty low, but this time what is different is that we were given a direction to build a hybrid cloud that would allow us to protect us from the vendor lock-in, and at the same time enable a seamless migration of workloads between the private data centers and the cloud. So let's look how we did it.
So as Jacek said, we wanted to support a hybrid cloud. So we still had multiple data centers, both on-prem as well as in AWS at the time. And so we selected the product called OpenShift in partnership with Red Hat to allow us to build Docker containers. And then the idea was that wherever we deployed an OpenShift cluster, we'd be able to deploy our containers. And that way we could have a container running in the cloud, running a Docker cluster, OpenShift cluster running on an on-prem data center, and we could be able to run the same code in both places. So our build process was updated, so developers actually go and build Docker containers. So they have modified their Jenkins pipelines to do that. We also wanted to introduce some concepts of security into our pipelines. And so we had this idea of what we call scanning their artifacts. So they would actually scan their container and the artifacts that go on that container. And we'd scan them with Veracode and IQ scan to look for open source licenses and vulnerabilities in the libraries being used on those containers. And once that pipeline determined that the teams passed the scan, it would be passed into our trusted application repository, for which at the time we'd selected Nexus. And this would allow us to have untrusted artifacts that would allow developers to build on demand and deploy those into a development cluster. But for certification and for production, the developers would have to scan artifacts, and the pipelines would only allow trusted scanned artifacts to move into those upper environments. So developers would then be able to go in and determine how they wanted to move through their environments, from deploying to dev, maybe deploying to a testing cluster, deploying into cert, deploying into prod. So the orchestration of how the development teams would be able to move their artifacts through the different environments that their service or application needed would be self-defined by the developers. Some teams selected Jenkins to be able to go and trigger this. We also developed a tool in-house called Armada that would, by default, move an environment from through the environments defined by a development team, from dev through to production, and also provide information on what artifact was deployed, what version, in what artifact or what destination cluster. So this would all be self-defined by the developers. On the deployment side then, we introduced a REST API in ServiceNow that would allow us to auto-generate through an API all of the changes that the development teams had prepared. And in that change, they would provide some automation data that was basically a JSON table or a JSON set of data that would provide information on where to find the artifact, so where in Nexus was the artifact located, and where is the destination of where that artifact was expected to go. So this would be whether it's going to which cluster and which namespace. And that would allow any of the deployments to be automatically or auto-generated without any human involvement. You'd be able to go and check in your code after you built it. It would start down its development pipeline, and every time if I was going to deploy to dev, it would create that request. The only thing that would require manual steps then would be the manual approval to go into certification and production. But once that approval was granted, a central container pipeline would execute based on using that automation data that was described in that JSON. And that would go in and copy the artifact from Nexus. It would then apply a centrally defined Ansible playbook that would know how to deploy the container. We did a blue-green deployment model So the existing container would be deployed, verify that it worked, scaled up. Only after it had scaled up would it scale down the old instance of it, and verify with any health checks and metrics that the newly deployed container was working in the selected environments. This was the same process then that was applied to all the clusters, whether it was certification and production. The only difference between the environments being who would have to approve it. So for development, those changes were deemed to be very safe. So those were auto-approved. So it would create a change, but that change would get auto-approved and deployed on demand. For certification and production, those would go based on the regular characteristics of that application. So if it had to go through like a CAB approval, those approval process would remain the same, but once approved and within the time window selected by the developer, the automation would automatically execute the deployment for them. So we had a lot of success in this. We were actually able to get our first fully automated deployment where all the developer had to do was check in code and it would automatically move through the pipelines into development, move into cert with one approval, and then move into production again with that one manual approval. And so we had a decent amount of success with it, but we had a few challenges. The first challenge was this basically required teams to do greenfield development. A lot of the services within Sabre don't necessarily fit well or didn't fit well into containers at the time. And so a lot of the development was for teams only doing greenfield work. So there was a little bit slower uptake. The second item is at the time, there were not good processes available for maintaining stateful information, databases, et cetera. And so we only actually implemented this for stateless services. And that meant that if you had data that needed to be changed at the same time as you were deploying application code, the regular manual processes applied for the data changes. So that limited the uptake, and into production, we probably got on the order of maybe 100 to 100 services or so deployed into production using containers using this model. With we probably peaked about 145 changes a month into production using this. But we also had some successes with it. We were able to go in and had shared infrastructure. You could look at multiple teams not having to develop their own policies and governance. It was a shared governance across all of this. And we learned a number of things about how to organize.
Okay, let's look at how you are set up from the organization, how you worked. On top of the key change here is from the first phase is we have the platform team. This is the team that was created after we decided to build a hybrid platform. That team very quickly adopted a mindset or the approach of using the platform product management, like a product driven approach for the platform. So internal platform as a product model with all those practices around it, interactions with users, treating this as a product, having very close user cases and the roadmaps and the enablement, documentation, training, onboarding, all the stuff that you would expect from the modern platform. The team understood that either the scope is too big to create a hybrid platform for everything. So like David mentioned, we limited it only to containers. And based on this approach, we organize our teams into the platform team into independent streams. One was looking at the CI/CD, monitoring, messaging, and stuff. Overall, there were a couple of learnings from that phase. I think the most important learning was that platforms of product, they're harder to set up because there are some additional steps when kicking off something like this. You have to do this is a little bit harder upfront but this is definitely beneficial long term. It leads to better solutions because the interaction and the feedback from the users give us this kind of correction function. And the second is that the fact that this is long-term team and the long-term platform, it tends to create solutions that are better, more maintainable. So this is definitely lessons for the future. The second lesson is that containers are not for everybody. Depending on the team maturity and the life cycle of the component or the product they run, sometimes it is not worth the effort. Moving somebody to container is not necessarily a good thing for everybody. So not everybody is a good fit. And final lessons from this second phase is that building a hybrid cloud in 2018 or 19 internally was slow, was expensive, and it was hard. And after, I think, 18 months of doing this, we were at a spot where we noticed that one more time that our progress is not sufficient, and if we continue on that trajectory, we won't be successful in long run. So again, we saw that we have to make some changes. So this is how the phase 2 ended, and we enter phase 3. In the phase 3, the urgency of migration is way higher than it was ever before. The risk profile is also a little bit higher. But this time in the third phase, we are going to solve our problem of the vendor locking without technology by partnership. As you know, Sabre signed a 10-year-long partnership with Google. We adopted mono-cloud strategy. And with mono-cloud strategy, we fully embrace GCP. So with that, let's look how that works.
So as Jacek said, building a hybrid cloud was hard. And in fact, we ended up only deploying production clusters into AWS with OpenShift. We had some prototype work done with deploying clusters into an on-prem data center, but we never actually got those set up for use in a production environment. They're only being used for development. So the biggest change that we did with the partnership with Google is decide that we're going to focus on a single cloud provider. So they're offering, instead of using OpenShift, they have a Kubernetes engine, GKE, that we would select to migrate our containers into. The second thing is we needed a solution that would also support those services and applications that didn't necessarily fit well, or we didn't have the timeline to migrate into containers. And so for that, we decided we would use additional services, native services within Google, or use the GCE environment with VMs to go in and create VMs to install applications on. And we selected, in partnership with Google, using Terraform from HashiCorp as a declarative way of defining all of those Google resources. So essentially, we're going to go down within Google and create pipelines to allow us to deploy containers into Kubernetes, or use Terraform as a declarative way to define the other Google services and resources that we would need. The other thing that we learned was getting the setup is very, very important. And we wanted to really focus on automation from the beginning. And being able to deploy into Google is fantastic, but there's a lot of setup work that has to be done. And so there's a lot of focus around building a self-service or a self-servant environment to allow us to do that. And again, with these, we would require manual approvals. So that would allow us to meet our SOX compliance requirements. So you can't just go in and build something in production. You need to get appropriate approvals. But we would have an onboarding tools that would help developers move on more quickly and manage things once they were there. And so this included things like code generators. So this would be if I wanted to create a sample container application, instead of having to figure out how to do it from scratch, we would actually have a code generator where you fill out the name of your Git repo, provide some information about the name of your application that you're going to build, and it would auto-generate in a Git repo for you an application that would build a container that would be connected to our pipelines so that you could deploy it into a dev pipeline within minutes without having to try to do all that setup yourself. Everything inside of Google requires a project or folder. And so again, all the project management, instead of opening up tickets to request to be done, was all done through a self-service portal that would be configured. You submit, I need a new project. It would go in and submit that request to the owner of the folder that it was in. Once they approve it, automation would kick off and complete the rest of that. And same thing with namespace management, firewalls, and DNS entries as well. The whole concept of being allowing developers to be able to do a lot of that work and set up their infrastructure in a much quicker fashion. From a build standpoint, then, as we said before, we used to build, our first foray was just building containers. So we still kept that option. So you can still build containers. A few tweaks to convert them from the OpenShift project configurations to using Kubernetes configs, but fairly straightforward migration for that. We also introduced something called Sabre 2, which I'll talk about in a moment. We decided for the rest of the Google services, as I mentioned, that we would support Terraform bundles. And we call it a bundle because it's basically a zip file that contain your Terraform, as well as any of the Terraform TFVAR files that you might want to include to generate your Google services other than containers. And then we realized that some teams needed the benefit of having a custom VM. So they may have VMs that take them a while to configure and stand up. And if you want to use that elastic capacity, it was one of the original reasons to move to the cloud. We want to be able to allow teams to go in and do that configuration quickly, create a custom VM from that, and be able to use that custom VM in their production environments. So that was another artifact type that we added. So Sabre 2 was this concept of streamlining the build process for developers. And it actually has three parts or three components to it. One is the idea of actually using a mono repo so that we would actually allow developers, instead of having to set up their Git repos and every Git repo looking somewhat different for each application, there'd be a shared format for building it. Originally, we were using Bazel to do the builds. It's been updated to support things like Maven and support C applications as well as Bazel. But it would allow us to do a CI as a service. So instead of developers having to stand up their own Jenkins instance any longer, if you build a artifact inside the Sabre mono repo, because the structure of the mono repo is the same for every directory, it allows the services then to be built in a consistent way. And so there's a CI as a service that automatically builds your components for you and allows you to trigger deployment, so the developers wouldn't have to do that. And then the third component of Sabre 2 was actually grabbing all of the typical developer tools that a developer would need to actually interact with our pipelines. So I need to interact with Nexus. I may need to have an IDE. I want to have Git installed, and basically creating a container that contains all of those build tools along with the custom Sabre 2 bash that would allow us to interact with the mono repo and provide that all in a VM so the developer doesn't have to stand all that up when they want to interact with these tools. They'd be able to just go in and grab that container and run that container and have all the tools they need to interact with our pipelines. The promotion process then remained pretty much the same as what we had with OpenShift. You would get your artifacts, publish them to an untrusted repository where you could deploy them into dev. And then if you wanted to get them into the trusted repository, you would have to scan them. And new pipelines were introduced for the VMs as well as Terraform bundles so that we could go in and make sure that they, if you're doing a VM, it has to have the appropriate labels on it. It needs to, we have an AMT, what we call an AMT, basically a startup script that installs security agents on the VMs. And so when the pipeline scans a custom VM, it verifies that that VM still contains our security tools and security agents on it. So those pipelines were added in. Once your artifact was scanned, it would be moved to the trusted repository. Again, the application pipelines were still largely the same. Developers can define in what order they would move through their environments, and they could self-define their environments. So when developers would create their GCP projects, they would be able to create projects in our dev networking cluster, or our CERT networking cluster, or our production networking cluster. And then within those projects, they could go and self-define what environments they are using. So they could have one project might be for their performance testing, another project might be for QA testing or integration, and then yet another one in production would be for their actual production running code. So the developers would still define those environments and how they wanted their code to move through those environments. And each deployment to those environments was what we would call a change request, which would be done by creating a request for deployment, describing your service, and using that automation data describing where to find your artifact, as well as where the destination was going to be. The pipelines or the approval process for that was largely the same as what we had before, although it was enhanced to not only auto-approve development deployments, because there's low risk in that world, but also start looking at other information and data points about the automation data and the requested change to see if we can start doing more automated approvals. So for example, if a service is defined as having no active customers yet, so if the team was migrating into production and they have no yet active customers, that service could be flagged as having no active customers, and they would be auto-approved to go into production without having to go through additional change of approval boards or any lead time or anything like that. In our centralized pipelines then, we migrated our OpenShift pipeline to become a GKE pipeline. We added a pipeline to support Terraform deployments, which would allow us to create any service that was supported by Terraform. We also have a pipeline for creating as well as editing and modifying GCP projects and folders. Same thing for namespaces, so developers can auto provision their namespaces and modify that, as well as firewall and DNS settings. This allows us then, a developer can go in and do the exact same deployment process into development, as well as certification, as well as production. And one of the big pushes is that we really were pushing on automation. And so a lot of the foundation teams building their tools were using their own automation processes to do their deployments as well. Something else we learned, we introduced the whole concept of SRE, so site reliability engineering, in order to support large volumes of production applications, especially those that were migrating from a mainframe or a more manual environment where they're maybe creating VMs and keeping some of their existing processes and not fully automating it. We have, as well as day two operations, where I need to go in and interact with the system. We started introducing this concept of SREs, and we brought in Zero Trust using CyberArk to allow you to get access to log into VMs as needed in production. And that way, instead of developers having SSH keys, every VM is managed through CyberArk and the Zero Trust environment that it provides. Then the SREs also brought into scope, instead of just doing monitoring on systems, starting to look at the concept of having SLIs, service level indicators, service level objectives, as well as even using error budgets, and using those data points as potential data points to bring into our approval processes to streamline how we approve our deployments and making that quicker. With this, we were able to see, we talked a little bit about these different sets of changes that we've seen. And just to give you an idea of the scope of what we've been able to accomplish over the last few years, going back to 2018, when we really started this process of moving into the cloud, this is the list of our manual non-automated CRs that we've done. And you can see that it's, and this is per month into production. The numbers, I've been told by legal, I can't give you actual numbers. So we've taken off the numbers, but it gives you a rough idea of the trends of what we've seen in the volume of production changes that we would manually do each month into production. Our first initiative going into OpenShift, you can see we peaked at about 145, 150 changes per month. But as we were seeing as we moved into January 2020, when we announced the agreement with Google, while we were seeing an uptick and we were being successful in deploying, largely because it was greenfield services, didn't provide a good option for stateful services like databases. It was going to take us a long, long time to really impact and see a change in kind of reduce the number of manual changes that we were doing. With GCP, however, you can see there was a much more rapid increase. And by March, April of this year, you actually start seeing that we're doing more automated deployments every month into production than manual. And over the last couple of months during the summer, we're actually starting to see a significant increase every month in automated deployments. And we're starting to see that migration as teams are shutting down systems in our on-prem and mainframes, that we're actually reducing VMs, and you're starting to see finally that downward trend moving in the number of deployments that we're doing manually. We talked about services as well, and that also paints a pretty interesting picture. If we go back to January 2020, when we were launching some of the OpenShift, this is the number of distinct services deployed every month into production. And you see it's remained relatively steady, although again, this summer we're starting to finally see those migrating applications are shutting down their systems on our mainframes, and our on-prem data centers have been shut down. You're starting to see those number of distinct services moving downward. OpenShift, you can see we got in the hundreds of services. We got about 100, 150 services that were actually deployed into production each month. But now with Google, you can see the trend is been steadily upwards. And again, this past month, in the month of August, we actually deployed more unique services using automation, where the only manual step is a manual approval process and verification, and everything else is automated. And now we're actually seeing more services deployed via automation into GCP than what we've been seeing doing manual changes. And we expect this to continue as we complete our migration of another several critical systems between now and the end of this year.
Okay, let's now look at how you work, how you organized. There are two major changes on this view comparing to the previous phase. First major change is that our Center of Excellence, Cloud Center of Excellence, adopted platform as a product concept. And now we have a cloud platform. This is the bottom rectangle. And that team is now focusing on enabling migration for all applications at Sabre. So this is not as we had in the prior phase when we only selected GKE. This is what David mentioned, that we are looking at everything. We want to have both stateless and stateful and legacy and new. So this is what Cloud Platform is doing. Obviously, all the practices you would associate with the product-led solution, with documentation, training, onboarding, enablement, and so on. Important part of this setup is that the Cloud Platform consists, or at least has a representation from the major teams that are required to make their work successful. That means all the security and networking and other functions are either included or represented. And I think that was a very big change. And the second change here on this view is that we no longer have our hybrid platform. This has been replaced with developer platform. As David mentioned, we decided to sunset OpenShift. We migrated all OpenShift users into GKE. Once that migration was completed, there was no point with the monocloud. There was no point of maintaining OpenShift, so we decided to sunset. Once the migration was completed, the team that was doing that work previously changed focus. Now that team is focusing more on the optimizing SDLC. So that team manages the CI/CD components, monorepo, which David mentioned, the Sabre tool and the toolset around it, and code generators and all those components that make developers work easier on top of the GCP platform. The key learning from that, from the third phase, is that platforms, both platforms in this case, provide high leverage. It would not be, we accomplished, what we accomplished with migration of, I think, like 16,000 servers to the cloud. Multiple hundreds of teams and thousands of people working in those teams. We moved to the cloud, and we are finishing like a 68 or 70% done. This is a huge effort. It is. It would not be possible without platforms. Platforms provide leverage. I cannot imagine doing the same thing without providing the common solutions that are repeatable. If you remember at the very beginning, David mentioned that in the phase one of the disadvantages of phase one, there was a lot of freedom, but there was no way to reuse what one team did in the other team. This is what platforms solve. And I think that was this is a key learning for us, that this works. So this is that setup I'm presenting here, we are presenting here, this is how we work today. More or less, this is what we are working. So we kind of went with our journey from the past, and we are at the present. So let's let the present time. Let's look a little bit about our next close future. We are still not done with the migration. So there are some things that we have to complete with the migration. So the migration remains our top priority. But on top of that, we got a couple of areas that we are exploring. We see opportunity from including addressing compliance requirements in the platform. Platform, like I mentioned, it is a very powerful concept. We see that we can help address compliance in the way that reduces cognitive load on team level. That way we can do it better, we can do it cheaper, and we can let developer teams do what they were focusing on, building great products for our customers. So that's one area. The second area is DORA and this DevOps journey. The way we see it is like right now we focus on the migration because that was our strategy. We wanted to make sure that we can get into the cloud and improve later, and this is what we did. We very quickly moved to the GCP, and now this is time to improve. We have to improve. We are using the tools. What we have to do is to change our habits and change how we work. I think DORA is a great compass on the journey. So we'll be using DORA guidelines, and we'll be using DORA metrics and the capabilities that DORA describes to push it further. We see that we believe that we can unlock a lot of value that hasn't been yet touched by releasing more faster, working the smaller batches and all those goodies. And finally, final not least, budgets is important. We are looking and exploring, how can we spend more our money in the more efficient way? How can we optimize our use of the services the way that we maximize value for customers and value for Sabre? And that is, I think this is the last slide, but there's a small disclaimer. David?
Yeah, what we've described here is a very high-level overview of our journey, and we really didn't touch on a whole lot of other things that have been involved in this. Migrating our MQs, the overall project plan of actually migrating, several thousand applications into the cloud and the management of that. Talking about our database migration, of actually migrating, Oracle databases into the cloud and how we manage that. Even the whole SRE journey, there's a whole presentation you could do just on that. So this is really not intended to, this is intended to give you an overview, but there's a lot of areas that we've not really dived into that we could focus on. And yeah, just as Jacek was saying, just as an actual number, I looked just before the meeting, and currently we've got about 28,000, just shy of 29,000 VMs running at Google as of this morning. So, from 2020 when we started the journey and we had, 0 to today where we're operating all of our shopping traffic inside of Google and running, 29,000 VMs successfully. We've come a long way. And it's been kind of cool to be able to be part of that and see what Sabre's been able to accomplish. With that, I'm going to stop sharing. And then are there any questions that people may have?
Yes, time for time for Q&A. The Q&A chat is open, or you can put items in the regular chat. There is one question queued up in the Q&A chat from Dan Cohn, familiar name. So looking back, it was on one of the slides with the deployments where it had manual deployments and OpenShift deployments, and then now the Google automated deployments. I was wondering if there's any. Looked like that there was a flat line of the non-automated deployments hasn't decreased despite the move to the cloud and automated deployments. Is there something that's behind those numbers that explains that?
Yeah. So this is actually the, I think this is the slide you're talking about.
Yep.
Keep it in here. Hopefully it's big enough for you guys to see. So on here, what we actually noticed, and it's a little bit hard to see on this graph because I was told to obfuscate it somewhat by our legal department. So that's why you don't see numbers and things like that. What you're actually seeing, there is a slow trend downward, but we're actually starting to see, particularly, there's been a huge effort on some of our largest systems that are migrating over. And they've been running in parallel, where they've been running in some of our existing data centers with requiring manual changes still, as well as in GCP. And those are starting to come off this summer. And that's why what you're actually seeing is the last 4 months since April in here are actually the lowest that we've seen in terms of manual changes in the last 4 years during the summer, outside of November and December, which are obviously our holiday travel where we have a lot of code freezes in. So we're actually starting to see that that trend happening over the summer, and we're expecting to see, and you're seeing the pickup as well as those teams are fully migrating over. And then from a distinct services deployed, this one's a little bit again, we're seeing this drop for the first time, where it's been lower for the last few months over the summer. The other thing to note is, as teams are migrating over, some of the services are being reused, and there's a handful that are still being used by our networking, and we have a contract with DXC where they still use some of those services. So there's a handful of manual changes where some stuff is still going in, but the vast majority are migrating over. So we're starting to see over the last few months in particular, and that was expected. This year's been the big push for the migration, and there's a number of significant systems that are going to be migrating in the third quarter, and hopefully they're done before the fourth, but third and fourth quarter. So we expect to see this continue to pick up as we head into the fourth quarter.
Okay.
One thing that I would add here, I think that may explain the shape of this graph is that some of those changes, not all changes are related to software. Some of them are firewall changes. Some of them are configuration on some devices, hardware like load balancers. Some of this will go away once we move to the cloud. I don't expect this chart to the pink one to go to zero. I think there is some level, and we don't know what it is, but I would say that some level it is that will basically abandon once we fully shut down the data center.
Yep.
Okay. Yeah. So that gives us a good idea why there's some stickiness in the manual items, but now, in the next 6 months, it sounds like there'd be a steep drop as Sabre makes it fully to the cloud, and some of the manual environments are turned off for good.
Yeah, we expect to see more. Yeah.
Corbin from Aviatrix has a question. Outside of the awesome partnership with Google, what other organizations or partners did Sabre consult with in the migration efforts?
So, Yossi, you may have some. I know, for example, we've met with HashiCorp that works with Terraform, and we've had ongoing meetings with them about support for enhancements to some of the stuff with Terraform. We've actually brought in Terraform Enterprise into our pipeline, so that's being used. So we have a good partnership with them. From a security standpoint, there's a number of partners. We use the Prisma Access for a lot of our security. So we've had a lot of partnerships in there, which, again, security is a whole other area that we barely even touched on here. Mm-hmm. So we've had good partnerships with them. And then Google's been a fantastic partner, providing, pretty much every step of the way in terms of partnering in terms of giving us support as well as recommendations on what we should do and how best to do stuff, and then learning from us as well. Being able to learn, they're running a real-time database that needs to be consistent across all 3 continents simultaneously is a challenge even for Google in certain cases. So there's things that they learn from us. Jacek, I don't know if you...
I'll add to this. I would definitely second the partnership with Google was great. As part of it, because this is so big, we were working with multiple PDP partners to basically augment our teams and expedite and close the knowledge gap in many places. 2 of which I work directly personally, I was very happy with were Quark and SoftServe. But there are more. So this is not exclusively, those are the things that the teams that I work with, and I had a very good experiences.
All right. Philip Buggs has a question relating to Oracle migration. So David mentioned that this didn't discuss the migration from Oracle and other databases to the cloud. Oh, maybe it's for me.
This is a
question on migrating and potentially modernizing these applications. Okay, maybe there might be.
Well, actually, I mean, on that front, I mean, there are teams that are actually looking at things like Spanner and using some of the native data storage inside of Google. In fact, that's an effort that we're seeing across the board pretty much, is now that we've committed to Google, step 1 is migration. So instead of doing a lift and shift, which is kind of what we did with OpenShift, we decided you're gonna write containers. You're gonna write good, cool code, and that'll make it easy to deploy. Our migration was, we got to get all of these existing systems into GCP quickly. And so to some extent, we're shifting them over and then we're lifting them afterwards. So we're making some minor changes to meet security constraints. All of their infrastructure is going to be built with Terraform. They're using automated pipelines to do most of their work. But there's still, Sabre has systems that are in there. So databases, a lot of the databases were migrated over. They're running on VMs inside of Google. So a VM is stood up, the database gets installed on it. To some extent, we're using similar processes to enable us to get the migration done. But at the same time, teams are looking at using the native Google services to replace that as we move on, where it makes sense, particularly with greenfield development. So some of our new systems like NDC that we've been working on, which is a product to a new distribution system with airlines, the backend for that is being developed natively using Sabre 2, using containers, and using native Google services. So where greenfield development allows us to do that, we're doing native Google services as much as possible. And then migrations by using the VM still allows us to migrate and get stuff into the cloud, get that footprint and cost savings that we need, while still, allowing us to enhance it.
All right. One thing I'd shout out that probably is one of those other things that can't fit into this presentation is the focus on Google Cloud education for the Sabre, not just the tech team, but everybody. I think we're at one point we were the 2nd largest consumer of Coursera's Google Cloud training, and I think I'm gonna get the number wrong, but I think we have like something 150 Google certified people at Sabre now, which is going from 0 to that is great. And some of those are even the Cloud Digital Leader certificates that are, that's like the entry step on the technical track, but then gets like product managers and others loaded with the cloud language pack so they can, understand cloud, and hopefully it's not a black box, to them as they go forward there. How has the overall cost profile been favorable? I mean, I can answer this one.
I can cover that. That has been shared. This is public information. If you look at the investor call, this is something investor information. This is something that we're reporting every quarter. I will get the numbers wrong, so please double check. And I was looking for it, but I think we dropped the kind of average server cost from like a 700 to 500 at the scale of 20,000 servers. So do my math. This is a significant cost saving. But I'm looking for exact numbers. But this is like a significant percentage, right? 20%.
It's on the order. I believe the number is on the order of like $100 million a year in cost savings that they're expecting moving forward. And the other interesting thing from cost savings, and this kind of goes in with the learnings as well, is we've got we now have weekly meetings. So with great power comes great responsibility. So the development teams now own their projects and folders. They can self-manage that. They can do automated deployments, but they're now responsible for the cost of those resources and being able to, we can now track the cost back to the projects, which is really cool. But it means that we have like a weekly meeting now on cost savings and going through and sharing with teams, where is the spend on their Google resources? How can they bring that down? And the teams are able to go and share practices that they're learning and best practices on that area, which is something that, it's kind of cool in the sense that you can go like on a Friday afternoon, go to look at your projects and see, are there resources that you don't need anymore? Go shut them down for the weekend, set up automation to shut them down if you can. But look around for stuff. And it's been a great way to share that information and get more of a user community around that. And if you as a developer picture the world of static VMs, physical VMs where you're going in and it takes you 6 months to get it and you repurpose it and do lots of stuff with it. Nobody really knows what the cost of it is. Well, now it's very apparent what the cost of stuff is. And it's a different world for developers, which is both helpful and somewhat dangerous. If I go and kick off a test and leave it running all weekend, I could spend a lot of money. But we've seen a significant amount of cost savings, and I thought it was on the order of about $100 million a year.
150. This is the projection for this year.
There you go.
On common components like GKE, talking about having developers, be able to focus on their own costs. Have you seen a way to do chargeback for common components?
From my understanding, it's like we are not doing chargeback on the GKE. The cost of GKE is slightly above the GKE we pay for the compute on the workers, and there is a very thin price cost on top. It was not worth it. This is not like we had in the P4 when we had a sizable cost of the OpenShift. In case of GKE, that makes no sense. I think I would need to double check the current prices, but that was something that we basically ignored.
Yeah, it's basically we're paying for the nodes. But on the flip side, we do internal because we use shared clusters. So teams deploy to shared clusters so they can be managed centrally. There is reports internally that are sent out to each development team by namespace. So the teams can go and see what capacity is being used by namespace and be able to manage costs that way.
Okay. Yeah, so we're using the Kubernetes namespace allows us to slice that up and let teams dive into that.
And we have, just to let people know, I mean, scale-wise, we got, last I checked, about 3,000 GCP projects that we run, and then we probably got, 1,000 namespaces, kind of that order. Okay,
that's to give everybody an idea of the magnitude of projects out there. All right, so just about at an hour. There's one final question I asked all the presenters. It's not technology. It's a career question. Career question. So if you could go back in time and give your 20-year-old self some career advice, what would it be?
Read more books.
It's a great question. What would I tell myself? Go take that job. Go take that job at Apple.
Read more books. Everything that we are doing, somebody already done. Somebody from the technology changes, but the processes remain. The mechanics is the same. There's very few things that are happening new. Somebody already wrote a book about it.
Reading's good. Learn foundations. There's principles of computer science. I've learned to appreciate the education I got at my university, where there's the principles of computer science don't change that often. And what you're finding, even in the cloud, a lot of the principles remain in terms of, how you write your code, how you optimize your code. We have different platforms and different ways of doing it, but understanding the basics is still really, really helpful and really valuable. And anything you do to learn that is good.
All right, that's awesome. All right, so what we'll do now, and thank you guys. It's been great for taking an hour to share Sabre's journey, even if it's just a thin slice of what's been available. Thank you to everybody for joining. Hopefully you've learned something to take away from it. There will be a recording, should be up probably by Monday. If you find that you want to share this with your colleagues or with your group, definitely thanks. I'm gonna do the quiet clap. The quiet clap. Thank you.